on the topic SAP IBP, specifically demand planning process. To start with, just a minute. Just a minute, there is some lag, I guess. Okay, is my screen visible?
Yeah, we can see it.
Okay, to start with, I will discuss on some model configuration topics. Let me first talk about attributes. So attributes are the characteristics of master data types. For example, there can be a master data type product, and product ID, product name, product category can be the attributes of product master data type. Similarly, uh, customer ID, customer name, customer location, all these things can be the attributes of customer master data type. So the following types of data types are supported for attributes: n, varchar, decimal, integer, timestamp, and the app name through which we can configure or create new attributes is the attributes model configuration. Coming to the next one, master data types. Master data type is where all the relevant or the key information related to a particular category is stored. For example, product master data type or location, customer, currency, exchange rate, etc. Wherein the product master data type will have all the relevant or the important information related to the product, such as product ID, product name, basically all the important information that is required for the product. Similarly, customer master data type will have all the relevant information regarding the customers. There are few different types of master data types, such as simple, compound, reference, etc. And the app name through which we can configure master data types is the master data type model configuration. Uh, Time profiles. Time profile is the time interval in which we want to view the data or for managing the planning data. Now, this time profile level can be made up of time profile levels such as yearly, monthly, week, technical week, quarter, etc. And each week level is then made up of periods which are identified by a number, wherein we describe the start time and end time of a particular time period. Then, if you want to perform aggregation, disaggregation along the time, then the periods must form a hierarchy. The year will be at the top, then there will be quarter, then month, then week, technical week, so on. And the app name is time profiles model configuration. The next is planning areas. Planning area is the overall structure or the backbone of the planning process. It is like a container which consists of time profile, attributes, master data types, key figures, planning levels, snapshots, and versions. And we can create a planning area by directly copying it from the unified planning area SAP IBP 1 or SAP 6, that is specifically for the demand planning purpose. The app name is planning areas model configuration. Coming to the planning level, it represents the granularity of the data. I mean, at which level we want to see the particular data. For example, week prod log cust, like we want to see the data, we want to see product location customer in week level, or month prod. At month level, we want to see the product data. So it is helpful in performing the aggregation and disaggregation. And the app name where we can access the planning level or create planning levels is the planning areas app itself. Then comes the key figures. Key figures are like metrics. I mean, businesses or the end users use key figures to view the data. The data is stored in a key figure. For example, the values of actuals quantity will be stored in a key figure named as actuals quantity. Similarly, The statistical forecast quantity will be stored in a in some or the other key figure, maybe with the name statistical forecast key figure. The app name is planning areas, and there are different types of key figures: stored key figure, calculated, or stored and calculated. Stored key figure, the data is either entered manually or it comes from the ECC or the ERP or some database. Calculated key figure means we can perform calculations using key figure. For example, if we want to add 100 to the actual quantity, then the formula or the calculation would be like actual quantity adjusted at a particular level, let's say weak prod log cast level, is equal to actual quantity at weak prod log cast plus 100. That means we are adding 100 to all the values in the actual quantity key figure. Similarly, stored and calculated key figure is a combination of stored and calculated key figure. For example, key figure 1 plus key figure 2. Here, key figure 1 may be a stored key figure and key figure 2 might be a calculated key figure. And we are doing some operations using the two key figures. The planning operators. There are different types of operators such as snapshots, copy operator. Snapshot is basically a saved version of a key figure at a specific point in time. The statistical, if you want to compare 2 weeks statistical forecast quantity, we can take the snapshot of a particular week and then compare that snapshot with the next week's statistical forecast. So it helps to keep track of our historical data and compare forecasts in order to do analysis. And there are different types of snapshots. Rolling snapshots, that means the latest if at this week we take a snapshot and that is stored in snapshot A. Then in next week, the snapshot that will be taken will be stored in snapshot A, and the snapshot which is there in snapshot A will roll into snapshot B. And then manual scenario snapshots, etc. And the application name through which we can access snapshot is the planning areas. Coming to the copy operators, we can copy the values of a key figure A to a key figure B. Here we have to choose a source key figure and a target key figure wherein we want the data to be copied. The app name is copy operator profiles, and then we can run the copy operator from the application jobs. Now let's talk about the demand planning process. The first step is load actuals quantity, then history cleansing, time series analysis, statistical forecasting, forecast adjustment, final forecast, taking snapshots or copy operators, then calculate custom forecast error. Then we finally, once everything is done, we finally release the final forecast quantity to the consensus demand, and then it is released to the supply planning. So we will discuss each one in detail. So the first step is loading the actual quantity or loading the transactional data. Generally, the transactional data and the actual quantity comes from the ECC, and it is extracted using the CIDS, or it is extracted using the CIDS into the IBP system, or it can also be uploaded manually using the data integration jobs. The second step is ABC XYZ segmentation. Um, ABC segmentation is done to classify or categorize the data, categorize the products based on the importance, such as based on the importance or the revenue generated or the value that it holds in the market. A categorized product is highly important products, and focus should be given to that particular product because it generates high amount of revenue. Similarly, C categorized products is low value generating product, or it is the lowest important product. Then XYZ segmentation is done to classify the data based on the variability and the predictability. Uh, X classified product is the product that is quite stable and consistent, and predictability is also high. So major attention should be given to X classified product. Then Z product is is highly variable, and the demand is also quite irregular, and lowest predictability. This is the ABCXYZ matrix, where AX classified product is top priority and stable demand, and most high importance must be attention must be given to AX classified product. CZ is the low value and erratic demand. The demand is quite irregular and predictability is also quite low. The next step is history cleansing. There might be cases like our actual quantity might have certain missing values. So, if we directly process the actual quantity without doing history cleansing, then this might result uh, into our forecast quantity, into statistical forecast quantity. It might give error, or there might be some variations in that, which might not be correct. So we need to substitute these missing values. We can do it either by using mean or median, or there might be a case our data set, the actual quantity might have certain outliers. Outliers are the extreme values, and because of that, it might the forecasting result might not be correct if we directly do the forecasting without doing outlier correction. So for outlier detection, there are two ways: interquartile range test and the variance test. In interquartile range test, we first sort the data in ascending order. It is an algorithm. So it sorts the data in ascending order, then divide the data set into two halves. Then it first calculates the median of first half and median of second half, and IQR is the difference of these two medians. That is, as you can see, Q3 minus Q1. Then the lower bound is Q1 minus multiplier into IQR. Generally, 1.5 is used as a multiplier, and upper bound is Q3 plus multiplier into IQR. Then comes the variance test. Here we calculate the mean of entire data set and then calculate the standard deviation. Then finally, the lower bound is mean minus multiplier into standard deviation, and upper bound is mean plus multiplier into standard deviation. And once these outliers are detected, it can be corrected using mean or median. Then comes the time series analysis. So, time series analysis is a process of analyzing the pattern or trend in the historical data in order to predict or in order to do the forecasting of the future data. So, properties such as seasonality, trend, white noise, intermittency, lumpiness are identified, and based on what properties our data set shows, based on that, a best fit algorithm is chosen to do the forecasting. So, the app name is Forecast Automation Profile. Uh, Step 5 is statistical forecasting. Statistical forecasting basically, as we have analyzed the properties or the patterns in our historical data, now we can do statistical forecasting to predict the future data. So there are multiple forecasting algorithms that are there. For example, moving average. Moving average, it averages the past data, and basically it is used when the data set is quite stable and fluctuations are also quite low. Then weighted average, weights are assigned to the historical data, and generally the recent data gets higher weight, and it is used when the recent data impacts the future data a lot. Then there are different smoothing algorithms like single, double, triple smoothing. A single smoothing algorithm is used when single exponential smoothing algorithm is used when there is no trend or seasonality in the data set. Double exponential smoothing is used when the data shows trend but no seasonality. Triple exponential smoothing is used when there is trend as well as seasonality in the data set. Now, then if the data set contains has some intermittency, then Croston's algorithm is used. So whatever properties or pattern our data shows, based on that, the best fit model is generally chosen. And if we and the best fit model is chosen. Before choosing the best fit model, it calculates error, and the model that shows least error is chosen. So to calculate the error between the forecasted quantity and the actual quantity, first exposed forecast needs to be done. So exposed forecast is extrapolation of the forecast numbers into the past. For example, if we want to see how our model does the forecasting for January 2025, and currently we are in May 2025, then the algorithm will use the historical data up to December 2024 to predict the forecast for January 2025. And using the exposed forecast, because of exposed forecast, we can see how well the algorithm is working. And we can compare it with the actual quantity of January 2025 and see the result of forecast algorithm. And based on that, if the error is least, then we can choose that then that algorithm is chosen. Um, so as you can see, the for product FG126 at 1710 location, for this particular customer, in week 12 of 2023, the exposed forecast quantity, this is the exposed forecast quantity and this is the actual quantity adjusted. So the error would be the difference of these, and this is the percentage error, absolute percentage error, mean of absolute percentage error, and this is the mean of percentage error. These are different algorithms, and this diagram shows which algorithm should be chosen in which with which kind of data set. Now, alpha, beta, these are the coefficients in alpha, beta, in single, double, triple smoothing. Uh, when the alpha value is small, then more weight is given to the distant historical data. And if the alpha value is large, more weight is given to the recent data set. For beta and gamma, it is completely opposite. More weightage is given to the recent uh, changes in trend if the beta and gamma value are smaller, and more weight is given to the distant ones if the beta and gamma value are larger. So this is the alpha is the smoothing coefficient, beta is the trend coefficient, and gamma is the seasonality coefficient. Once the statistical forecasting is done, then the data is then copied to the local demand planning key figure. And if the local demand planner is satisfied with the forecasted quantity, then it goes to the global demand planner. Else, he might make certain adjustment, and the data with adjustment can be stored in local demand planning adjusted quantity maybe, and then it goes to the global demand planner, and same process is followed by the global demand planner as well. Um, Finally, once everything is done, it is then released to the it is then copied to the consensus demand plan, and then released for the supply planning. Now, coming to the CIDS part, CIDS stands for Cloud Integration Data Services, and it is used to basically extract the data from the ERP, and then it transfers it into the IBP system. For example, if NetSuite is the ERP, which has all the data, the master data values, key figures, and everything, then that is extracted by the Dell Boomi, and then it is placed on SFTP server. Then CIDS extracts the data from the SFTP server and then places it on the SAP IBP, and then demand planning or supply planning can be done. So this is the project that we have done, and I discuss in detail about these steps. Mm, yeah. The key figure with the name shipment history, it contains the actual sales history, and it is at the base planning level is week prod log cast. Now, if any manual correction or adjustment needs to be done, then that can be done and can be stored in shipment history override. Uh, then comes the backlog order. Backlog order is the confirmed customer orders that are yet to be fulfilled. Maybe the shipment date is in future, and that could be the reason why it is not fulfilled yet. So, uh, backlog order is at week or log cost level, and it is a stored key figure. Then backlog order ratio. The calculation for backlog order ratio is backlog order at week prod log level divided by the backlog order at technical week prod level. Then we have used shipment forecast single exponential smoothing, double exponential smoothing, and moving average for doing forecasting. And out of these, the best fit algorithm is finally chosen. Um, then the marketing forecast quantity. This in this key figure, the total forecasted quantity or the total uh, booking forecasted quantity is stored, and this is done by the marketing team based on the current trend in the market, etc. And it is a stored key figure at month prod level. uh, then marketing forecast DC, it is DC level marketing forecast or the booking, like how much quantity is expected to be needed at a specific DC. That data is stored in marketing forecast DC, and it is a calculated key figure with the calculation is um, marketing forecast at month prod level multiplied by multiplied by the Z backlog ratio at week prod log level. Then marketing forecast NVD. NVD is need by date. That means estimated shipment date corresponding to the booking quantity. Uh, where like we have to shift the values by the lead time, and that lead time must be updated in product master data. Uh, this particular an attribute with the name T lead time is first we need to create that attribute in product master data, and then we have to mention some value by which we want to shift the weeks. And then once everything is done, it will be copied to the consensus demand plan. So consensus demand plan is at week prod log level, and the calculation is marketing forecast NBD plus the backlog. uh, then if any adjustment needs to be done, then it can be done and can be stored in uh, the consensus demand quantity adjusted key figure. And finally, this consensus demand final will be equal to the consensus demand override if there are any adjustment made. Otherwise, it will be equal to the consensus demand quantity. And then we can take snapshots of we took snapshots of the backlog order and the CDP quantity. And then we had set up a job template that used to run history cleansing, forecast automation, and then statistical forecasting part, and this taking snapshot of backlog order and consensus demand quantity. Thank you. Hello.
Yeah, yeah, Palak.
Yeah.
It was really good. You explained in very detailed and clear manner the entire flow. Uh, yeah, it's the only thing I suggest is to add few images, so
Okay.
it looks like, because it's most of the like it's black and white, right? So
Right.
it's good to have images that maybe in the XYZ segmentation, right? So I think you
Yeah.
have created your own, but you can make use of there are some images which clearly explains what this ABC XYZ segmentation is in
Mm-hmm.
a graphical manner. So you can
Correct.
make use of, yeah, but still it's good what you put down. Yeah, overall it's very clear in detailed manner.
Okay.
Yeah, Pankaj.
Yeah, Pawan, same. I also have the same feeling. The content was good, well presented. The presentation, the talk, the thought flow was also very good. So all good. No much, uh, nothing much to be improved.
Right,
Uh,
right.
only thing is that in some places, little bit of screenshots will make it easy to eye. But other
Yeah.
than that, I think all good. Very nice.
Thank you.
Right. So I think we with that we comes to the end of this session. Let me first stop the recording.